Good afternoon to one and all present here. We are here to attend a technical talk on cracks in buildings by Mr. Karthikeyan. He's the chairman, Structural Engineers Association, Tamil Nadu, Chennai chapter, and MD of Karthikeyan Associates, Chennai. We welcome you, sir. I would also like to invite the HOD of the Department of Civil, Dr. V. Vandana Devi, to say a few words. Welcome, ma'am.
Yes. Hello everyone. Vanakkam.
Vanakkam, ma'am.
So, I feel honored to welcome the speaker of today's webinar, the Managing Director of Karthikeyan Associates and Chairman, Structural Engineers Association, Tamil Nadu, Chennai chapter, Engineer A. Karthikeyan. Welcome, sir.
Thank you, ma'am. Thank you, ma'am.
It's my pleasure to welcome my dear students, faculty, and the participants for this webinar. Our Department of Civil Engineering has arranged this webinar titled Cracks in Buildings, Causes, Prevention and Remedies for the benefit of our student community. This topic was chosen for two reasons. One is our final year students are undergoing the course Repair and Maintenance of Structures, for which this current webinar topic will give them the fundamental knowledge to learn the maintenance procedures. And secondly, cracks. This entire world is aware of cracks. Each one of us has seen the cracks in our homes, hospitals, classrooms, and even in bridges. As a civil engineer, we all must know how to prevent the formation of cracks, and if cracks appear, what to do, how to repair them, and hence this webinar. As a HOD, I have to say a few things about the cracks. Anyway, we have an expert member for that. Shear cracks in buildings occurs when there is large differential settlement of foundation. It may be due to the unequal bearing pressure at the different parts of the structure, or it could be due to the bearing pressure being in excess of safe bearing strength of the soil. It would be better to learn the causes, prevention, and remedies of cracks in buildings from an expert like Engineer A. Karthikeyan, sir. With this short note, let me introduce the resource person of today's webinar, Engineer Karthikeyan, to my dear students and participants. Mr. Karthikeyan did his undergraduate in civil engineering from RVS College of Engineering, Dindigul, in the year 1996. He has worked as a project engineer in an NGO called Cheru at Dindigul for a year. Then he joined as an assistant design engineer under an eminent structural engineer, Professor M. Chokalingam, sir. Engineer Karthikeyan did his post-graduation in soil mechanics and foundation engineering from College of Engineering, Chennai University in the year 2000. He has presented several papers in national level seminars and international conferences. He started his own business and has been a successful entrepreneur practicing as a structural and geotechnical consultant since 2000. He has completed 2000 plus projects, which includes construction of residential apartments, schools, colleges, hospitals, hotels, temples, churches, mosques, shopping malls, industrial buildings, radio towers, and bridges, earthen dams, machine foundations, rehabilitation of structures, underpinning, earth-retaining structures, and the list goes on. Though he is an entrepreneur, he likes to mentor the students, and hence he has served as guest faculty in College of Engineering, Anna University, our Hindustan University, and also at Micro, Small and Medium Enterprises, MSME Gindi. He has also served as an adjunct faculty in Tyagaraja College of Engineering, Madurai, and he has delivered various programs and guest lectures in various technical associations and academic institutions. Currently, he is holding the position of Chairman, Structural Engineers Association, Tamil Nadu. In short, we call it as SEAT, Chennai chapter. He is also a patron member in Builders Association of India, BAI. He is also a member of Institute of Engineers and Chartered Engineer. Engineer Karthikeyan is a recognized professional engineer by Engineering Council of India. He is a fellow in Institution of Values India and also a member of syllabus subcommittee for soil mechanics and foundation engineering, which is a favorite subject for most of my students. So, sir is the syllabus committee member for the course Soil Mechanics and Foundation Engineering at Anna University. He is a member in Indian Society of Structural Engineers, and he has also signed MOU with GCT, Government College of Technology, Coimbatore, and also KCG College of Technology. He has received Best Engineer Award from JSW Steel, and he has received the Ultratech Award 2021 from Indian Concrete Institute for Best Built House. Sir has also received Best Webinar Award in the year 2022 from Structural Engineers Association, Tamil Nadu. Engineer Karthikeyan received Construction Industry Award in 2022 from our Honorable Governor of Tamil Nadu, Thiru R.N. Ravi, for excellence in structural repair and rehabilitation. Other than design office, he is also running an academy for civil engineers in the name of Karthikeyan Academy for Civil Engineers at Arumbakam, Chennai. He has trained nearly 20 engineers, and most of them are placed in various companies in India and abroad. Over to you, sir. We are waiting eagerly to listen to you, to your lecture, sir. Please. Thank you.
Thank you, ma'am. Thank you for a long introduction. May not be boring for the students. One thing I want to share, my personal opinion. I'm a good structural engineer because while I was studying B, most of my areas were in success. So there itself I started rehabilitation of myself. So the governor of Tamil Nadu gave best rehabilitation engineer award. The rehabilitation start from the BE. I rehabilitate myself from structural engineering, and then I started my career. Okay, this is just for fun I am sharing, and also for the students who are having not scoring much, need not worry much, because what you study is one thing, one part of life, and what you are going to practice is another part of life. So in one innings you may fumble and you may struggle, but another innings is totally different. So for that you need a lot of hard work, patience, and continuous efforts. Okay, this is about engineering applications. Let us go straightly into the presentation now. Ma'am?
Yes, sir.
Cracks in building.
Yes, sir.
Hope everyone have appreciable vision.
Yes, sir.
One of the disadvantage of being a civil engineer or structural engineering student or being a civil engineer, you may go to a reception, your aunt, your uncle, your friend call you, I have a small crack in my building, can you come and see what is the reason? So there your interview starts. So being a civil engineer, being a structural engineer, you cannot avoid such circumstances. If you solve the problem, you become famous. If you don't solve the problem, you have a negative popularity. Even though you are a civil engineer, he may be a PhD, but you don't know how to solve small cracks. There are numerous research begin to witness these cracks, but there are solutions are different for different type of cracks, different type of solutions. I say the crack in building equal to cold and cough for a man. Cold and cough may be 1 or 2 days, it may go off, or cold and cough may be corona, or cold and cough may be a TB, it may kill the man. Similarly, cracks may be a minor crack, it may vanish with minor putty finish, or sometimes it may lead to corrosion, it may lead to use indication for collapse of the building also. So we have to elaborately study about what is crack. Crack is nothing but a line or series of lines of disintegration of particles. If the particles goes away from each other, then only crack starts. It may be a small particles or even concrete coarse aggregates. If they goes away from each other, that is the creation of cracks. Cracks are symptoms of distress. If there is a crack come means it's a symptom. You are coughing, okay, you are sneezing. That is a symptom. Something is inside your body. You are not comfortable. So cracks are the symptoms of distress. If the crack comes in a building means something wrong. Why building get cracks? When stress increases its limit, or when deflection increases the limit. There are only two reasons. Majority of two reasons the cracks comes in a building. One, the stress may increase or the deflection may increase. Once you lower the building, the stress develops in a building. Every building will withstand stress. In student life, people have faced exams, so the syllabus are heavy. Normal days, our stresses are less. In exam days, the stresses are more because syllabus is more. Within stipulated time, you have to prepare. Within stipulated time, you have to write the exam. So stresses are more. After the examinations are over, your stress is released. You are free. You feel very free. Similarly, in buildings, when people are accumulating on buildings, when loads are accumulating on buildings, the stresses develops. When the stresses develops beyond the limit, then the breakage, the failure occurs that creates cracks. Similarly, deflection. You sit in a chair lies slightly deflect. Similarly, if there are a lot of people sitting on or standing on a building, the building slab slightly bend, it does not notice by anybody, that's okay. But if the deflection is more, then there is a chance of cracks on the slabs. When stresses goes beyond limit, mostly overloading. People, that hall is designed for 200 kg per square meter, that is 2 kilometer square. Due to some occasions, more people may occupy one floor or one room or one building. Sometimes it is designed for residential building. They let it out for commercial purpose. The person taken for commercial purpose may store more materials. So the live load increases. Like that way, overloading. Or they designed for 1 plus 3 story or 4 story only. But people construct 2 more story over that. So it is overloading. The building does not achieve expected strength. People designed for M30, M40, but many people don't achieve even M20 grade. So whenever the designer expecting something, the contractor or the site people might not achieve equal to what is the expectation of the design requirement. So not achieved expected strength. Shock or impact. There is a corner you can see. Okay, there is a stilt floor column. It's a car parking where the car may hit your column. It's a shock. During construction, the JCB or lorry may hit the building. So that is a shock or impact. So that also is to be taken account for design. Okay. In industrial sectors, this is very common. There are cranes and a lot of moving equipments are there that may hit the columns. And joints and connections. All the materials have numerous joints. Column to beam joint, foundation to column joint, column to beam joint, beam to slab joint, and masonry to floor joint, floor to opening joints, a lot of joints. In every joint, there are different type of materials. Different type of materials have different type of properties, different type of coefficients. That may not match compatibly, then there is also chance of cracking. And reverse stress or reverse force. Normally, people are designing for a sagging moment or rocking moment. But some unexpected conditions like earthquake or cyclones, there is a chance of reverse flow of forces. For that, the reinforcement might not be detailed or the materials might not be designed for that. In this case, cracks may come. Loss of contact area due to alterations. one person purchase a flat in the 4th floor or 7th floor, he feel lot of hindrance walls. He want a free space. He may remove some walls. He may alter some beams. At the time, due to alterations, some deficiency in design may occur, or they violate some designs parameters, then there is a chance of cracks. And sinking of supports. If there is a framed structure, the columns are setting on at different locations. If one column sinks means what happens here? The beam column joint sinks. Okay. Here, the beam column joint sinks. If the beam column joint sinks, there is an additional moment. For the additional moment, that may create some cracks on the beam column joint or even on at the wall. What are all the limit for stresses? Every material has, or every member has, the allowable stresses. If it is a tension member or if there is a tensile force, in RCC structure, 0.72 FCK is the allowable flexural stress. For steel structure, Fy yield strength divided by 1.1. I think
Fine, sir.
there I
Yes,
left. I think. Is it, ma'am?
Yes, sir.
Previously, I left it here. Where the limit for the stresses.
Yes, sir. Yeah. Please proceed.
So, if the tensile forces increases, the tensile flexural values, then there is a flexural crack or tensile cracks. Similarly, if there are compression crack, if you overload the structure, there is a chance of more compressive stress. If the compressive stress more than 0.4 FCK, there is a chance of compression cracks. If the shear cracks, that is, if the joint of, like a scissor, if you take a scissor, if you take two knives acting parallelly in one direction, the paper or your cloth will not cut. But in a scissor, there are two opposite reactions. One is action, another is reactions. If you introduce a paper or a cloth, the scissor cut. Similarly, when there is a beam column joint or beam column foundation joint, wherever there is a joint, one action and reaction is there. When there is an action and reaction, there is a chance of shear crack. So the shear stress should not be exceed more than 0.25 FCK in concrete, 0.524 Fy in steel. In flexural cracks, already discussed, it is a tension 0.72 FCK, 0.66 Fy in steel. Punching, when a column meets a foundation, there is a chance of punch. That is, column's area is very, very less when we are compared to foundation area is very big. So there is a stress concentration that is called the punching stress. If the punching stress more than 0.25 root FCK, then it is creating cracks. Am I audible, ma'am? Am I audible?
Yes, sir. Yes.
Okay. So bearing, when the material go and rest on another material, the parent material receives, that is bearing. That is why we are calling bearing capacity of the soil. So bearing means whatever going to rest on it, the parent material has to receive it. In case of RCC, that is 0.45 FCK, where in case of steel, Fy divided by 1.1. So this is all the stress limits given by our IS codes. So if the stress limits are increasing, one of the major mistakes what we seen in some designers, they very nicely designed in the softwares like STAD or ETAPS and all, but they don't check whether the stresses are within limit. Because while a designer designing a building, there are a lot of constraints for him. one is the architect say the column size should not be more than this or beam size should not be more than this. So he has to reduce the member size as much as possible by architect's compulsion. Number two is the contractor. This is the formwork availability for me. This is the section available from our shop. This is only the economy for this building. So people goes on seeing the members more. If the stresses are beyond the limit, there is a chance of cracks. Deflections. As I said earlier, architectural constraint or contractor constraint or economical constraint, we make slender members. Nothing wrong, but this slender should not increase the stress and should not be more deflectable, more deformable. Due to overloading also, the members get deformed. Lack of sufficient depth or structural members. Our very first introduction in Swanta materials or engineering mechanics or applied mechanics is moment of inertia. I equal to B dq by 12. So in case of IS 456 or IS 800 also, very much concerned about span by effective depth ratio. They are very silent about width ratio. Okay, they are very strong on if it is a cantilever 7, if it is a simple support 20, if it is a continuous 26, and if the span is more than 10 meters. Second time, sorry.
It's okay.
So lack of stiffness is the another important thing for more deflection. If there is a more deflection, there is a chance of cracking. And deliberate removal of supports after construction. Sometimes architect want to remove a column. People blindly remove the column, and simply beam become a cantilever beam that will deflect more. And premature removal of formwork without proper stripping time, that also leads to cracks. There are types of cracks we can classify into two types. One is structural cracks, another is non-structural cracks. Structural cracks are nothing but the cracks on the structural members like columns, beams, slabs, walls, etc. Non-structural cracks are nothing but the cracks on the plastering and cladding elements. Non-structural cracks you need not worry much, but structural cracks giving some warnings. Something is wrong. But common people, they don't know what is a structural crack, what is a non-structural crack. They fear for cracks. This is one famous book by UK publication. They classified more than 17 type of cracks. If there is over reinforcement, on a section, so there is a sinkage issues between reinforcement and the concrete, there is a chance of cracks. And arching effect, because of the local arching effect, there is a chance of cracks. And this is a very common crack in concrete surfaces, that is plastic sinkage. When you apply a concrete, and then there is a moisture evaporation. The moisture evaporation creates sinkage, that is a plastic sinkage crack. And in case of beam column joints, there is a sudden depth reduction and there is a chance of cracks. This is also another plastic sinkage crack on over reinforced sections. In case of RCC, people think more steel is more safe. That is a bad thinking. In this, if there is more steel with a very less spacing of the ductility issues again starts, and then no proper bonding between the steel and the concrete, and there is a process engaged due to over reinforcements. And alkali aggregate reaction, that is a different topic we have discussed elaborately. That is the aggregate, the coarse aggregate and fine aggregate reacting with the cement. That reaction may create some cracks. If there is overreactions that create cracks, and that create cracks. There are 17 type of cracks. We will go one by one. Before that, depends on width of crack. We can classify fine crack, that is less than 0.1, which is not visible by human eye. Am I audible?
Yes, sir.
Yes, sir. Yes.
The width of crack, if it is less than 0.1 mm, then it is definitely not visible by human eye. Even for working stress method, while designing of water tanks, the 0.1 crack width is allowed. In limit state method of design in RCC, thin cracks 0.1 to 0.3 mm is allowed. So this type of cracks, first fine and thin cracks, which is very difficult to see by human eye unless the microscopes are required. The third is medium cracks, that is only visible by a human eye, 0.3 to 0.7 mm. It is a microtip pencil lines. So there is a medium type of cracks. This type of crack only people first witness. Second type of crack is, there is a fourth type of crack is wider crack or wide crack. That is 0.7 to 2 mm width. So this cracks definitely giving alarming to the people in a building. Very wide crack. Is more than 2 mm cracks. These are very wide crack. People feel. So for different type of cracks, there are not possible to visualize. So treatments are practically not possible. From medium type cracks to the wide cracks, there are different type of treatments are there. There is a book called Special Publication 25, 1984 by Indian Bureau of Indian Standard. They issued a handbook on handbook on causes and prevention of cracks in buildings. They classify the major principal causes are moisture changes. Okay, in the season changes, there is a moisture changes and thermal variation. Both are depends on seasons. Okay, moisture changes and thermal variations, and elastic deformation. When you are sitting on a, and then you go out from the room, the deformation rebounds. Fatigue. Assume you take a thin plate, apply forward and reverse repeated deformations that create fatigue. 1 kg of apple or fruit, something in a plastic bag, which is proven, it should be prevented. Okay, you purchase in a plastic bag, carry bag, and you hook it on your any nail or something. After 1 hour, you need not add 1 gram of additional weight, but the plastic bag, because of constant stress, the creep creates cracks. That is also created on the buildings. Chemical reactions, as I told earlier, there is alkali aggregate reactions and other chemical reactions in the buildings that create cracks. Foundation movement with the soil and structural interaction, that create cracks.
Sir, excuse me.
Premature removal of armor.
Sir, there is
IS
slight
456 very
lag.
clearly gives up to
Excuse me.
6 meter. This much is the time required. Then I can hear you. Lag. Sorry, ma'am. I cannot
Sir,
hear you.
there is slight lag in your audio, sir. Yeah.
Lag in audio.
Yes. It's slightly interrupted, I guess.
Oh, because of phone. Is it?
Or maybe you have to keep it a bit away, I guess. Yeah. Please proceed.
Now okay?
Yes, sir. Fine.
Okay. Premature removal of armor. People put armor, on that they put a concrete. For this much span, this much is the strip of time. Before that, you should not remove the formwork. Sometimes due to some site conditions, some people they force the site engineer to remove the formwork construction schedule. So they remove the formwork. Okay. And fire damage. In some places, the fire may occur, accident may occur. The fire may damage the concrete or the masonry that create cracks on the building. And the vegetation, nearby tree roots are there that may penetrate into the building that may create cracks. So these are all the major causes of cracks in the buildings. This is very clearly given in the handbook on causes and prevention of cracks in the buildings. You can easily download in the net, SP 25, 1984. The moisture changes is the most important thing in particularly in clay soil. If it's an expansive soil, already the bearing capacity is poor, but the moisture creates very vulnerable chance of cracks. Assume there is you are not constructing any building on a land. It is a fertile land. Okay, the virgin land, nothing is there. So at that time there is a moisture. Some moisture content of 30% or 40%, let it be. Assume. You construct a building, a nice building, you construct all this. Now what happens? You are preventing the moisture to evaporate, is it not? Okay. You are preventing the moisture to evaporate from the soil. So the building prevent from sunlight, prevent the moisture from sunlight. Okay. The building protect the soil moisture. But outside the building, there are trees suck the moisture and evaporate. There are evaporation of surface water. What happens? There is a moisture imbalance. Outside the building, there is a dry. Inside the building, there is moist. If it is a clay soil, there is a sinkage. You may see in your paddy fields, there are a lot of sinkage. So sinkage is dominant around contact area. This the foundation is the contact area. The soil and the structural contact area create a lot of sinkages. Here the density is more because of more moisture. Here density is less. If the soil, the foundation is not enough to withstand the lateral pressure, then there is a slight movement. The slight movement creates the cracks. That creates a crack like this. In case of monsoon time, again this is reverse. What happens? There is a pouring of rain. The rain penetrate into the moisture, penetrate as a moisture, and make the soil as a sponge filled with water. And then they try to go inside your building by capillary or some soil permeation. Okay. Then this sinkage closes. The cracks also closes. People feel happy. The next summer comes, again the same cycle creates, then the cracks become still more wider. Because already the crack is still more wider. So be in case of expansive soils or clay soil, be very careful about to withstand not only for the load, also you have to take care of the moisture changes. There are a lot of precautions while you are going to construct a concrete structures. Number one is strict water cement ratio. In case of creating a concrete, people, you based on the brands of steel, the brands of cement, good brand Coromandel cement I use, L&T concrete I use, like that. But the water is very, very important. If you pour less water, there is no reactions. There is less reactions. If you put more water, the strength drops. So the optimum water to be used, okay, should be used. You may use Coromandel cement, you may use Tata steel, but if you use salty water, all your concrete become weaker. Okay, it may corrode your steel and make your structure weaker. So use good quality water. Okay. Ensure leveled formworks and shuttering. Okay, the formwork should be straight enough, and shuttering and props should be, you got double check, because once you load it, there is a small bend and tilt or settlement with there, so that will make the uneven shape and then chances of sinkage cracks. And ensure good quality materials. Purchase good cement. Cement should be used within the maximum of 3 months after the come from the factory. Preferably 1 month, maximum 3 months. Okay. Aggregates are nothing but sand and stones. Water, use good quality water. Admixtures, people use admixtures to improve the quality of concrete, but too much of admixtures also drain your concrete quality. Ensure proper proportions and mixing. After the M sand comes, before that we are use river sand. There is river sand color is brown color, and M sand, cement color is gray color. When M sand comes in picture, both are same gray color. So when you make manual mixing, people may do errors on mixing. Improper mixing is there. So that is another reason for less strength mortar. Less strength mortar creates cracks. Ensure correct slump value. Slump test we study in college. Okay. This instrument is matter of 2,000 rupees. If you go and check in Amazon, this matter of 2,000 rupees. Hope I am audible. Okay.
Yes, sir.
Okay. The slump test. Why slump test we use? To check the workability. I go to many sites, ask the site engineer, where is the slump cone? Sir, we purchased, sir. It is in the godown, sir. It is not mean to purchase take it in godown. Every concrete, the first 3 or 4 mass of batches should be checked and frequently checked with the slump. If the slump values are within limit as per IS 456 or as per concrete technology book, then only there is a proper workability and water cement ratio can be maintained. Due to improper slump, there is a chance of segregations and cracks comes. So slump cone is the most important instrument while you are making for concrete. People may to do cube ton strength and all nowadays because of the awareness, but people don't use slump cone. So slump cone is a very important instrument to do concrete. Extra care for cantilevers. Ensure main rod on top. We know in cantilevers, main rod should be on top. Yes, people provide, but they forget to provide chair rod. Chair rod is a small bent up rods to be placed. People walking on the cantilevers may make the cantilever rods to bend. Instead of the rod in the tension zone, it comes to compression zone. People, without knowing properly, they pour the concrete, and then there is a bend, there is a cracks, and even sometimes accidents happen in one of my site. Ensure sufficient compaction. You may use good material, but good methodology is important. So in case of concrete, use proper compactors, vibrators. Okay, then only you can ensure a good concrete will be there. Otherwise, the porous concrete may create cracking. Don't allow sleeves or openings in shear zones. Mostly in beam column joints, people make holes for sleeves for the AC ducts or pipelines or plumbing lines. So beam column joint is nothing but high shear zones. In these high shear zones, if you make an opening, definitely there is not only a chance of cracking, also collapse. And coat the reinforcement with anti-corrosive coatings and avoid corrosion cracks. So these are all the precautions to be used for precautions to prevent the cracks in concrete. Due to thermal variations, in our country, in Tamil Nadu, in South India, our temperature in summer is 45 degrees Celsius. In winter is 20 or 25 degrees Celsius. So 20-25 degrees Celsius variation is there. The top surface expand. When the top surface expand, there is a cracks on the slab and the wall junction. So people may think if you provide a beam, again there will be a less chance of cracks. Yes, if you provide a proper beam, there is a less chance of cracks. But my next slide shows even you provide a beam, there is a chance of crack below the beam. So how to avoid it? Okay. Most of the cracks are masonry, because in RCC the cracks are, other than corrosion, it will be some way withstand because of steel is there. So it will take care of tension, concrete take care of compression. So it will some way manage. It goes. But masonry is a brittle material. In case of masonry, more cracks or chances of more cracks. For that, choose proper brick units. That is very important. Bricks should be well burnt. Bricks should be well burnt. But
excuse me, sir.
Take the brick. Yes, I can.
Sorry for interrupting.
Yes.
There is a question on the chat. Would you like to answer that now, sir?
Yes.
Yes. So Rajesh Datta is asking, SBC of soil it plays major role with structural design in clay soil, can avoid cracks.
Yeah, SBC is purely depends on what is the size of the foundation. See, when you go back to my previous slide here, this person designed for the size of the foundation. This is the SBC. This is the size of the foundation. Okay, because he calculated the load is on the vertical direction, Fy. Okay, so only for load versus the bearing capacity, there is no issues. But because of the moisture variation, the inside moisture is more, the outside moisture is less. There is a push. If the substructure is not sufficient enough to withstand this push or swell, then there is a chance of movement. If there is a chance of movement, there is a chance of cracks. Are you comfortable? Are you satisfied, Mr. Rakesh or something? Are you comfortable? Are you satisfied? Yes, there is a lot of issues regarding soil sensor interaction. I will explain in further slides. Before that, let us go into brick units. People are in hurry to purchase the bricks. The bricks should be well burnt only after 3 weeks from the kiln or chamber has to be bring to the site. Inside, the bricks should be seasoned for 1 week. Okay. Why? Because the manufacturing temperature is different. Your site condition temperature is different. You season it for 1 week. And then the bricks should be sulfate free. This should be, if you have any doubt, you have to check it with the chemistry lab only. So it should be sulfate free. What happens if there is a sulfate? You are applying cement mortar with the brick units. The sulfate reacts with cement mortar, make it calcium sulfate. The calcium sulfate become a weaker material. It peel off and then become powder form. It will fell down from your masonry. So make the masonry weak and there's a lot of cracks. So it should be sulfate free. Wet bricks should reach the mason's hand. This is a very important thing. When site engineers scold the masons, wet the bricks, they wet in the morning and till the evening, they don't re-wet the mason constructing the brick masonry. They again, the site engineers scold the mason, why not you wet the bricks? He said, morning itself I wet the bricks, sir. It is not every day I am bathing. Okay. So bricks also bath in the morning. It is not like that. While the bricks has to reach the mason's hand, it should be wet. Why? Because In case of mortar, that has a moisture. If the bricks are not wet, it will absorb the moisture and make the mortar weak. Okay. And avoid rich mortars. Most of the clients thinks if you provide more cement, more strength. Yes, of course, in one way it is correct. In another way, in a masonry structure, 1:5 or 1:6 is enough. So sometimes 1:3 or 1:4 they put means more shrinkage will be there. Improper curing for the more cement mortar, more cement in the mortar, then there is a chance of more shrinkage cracks. So rich mortar should be avoided. What is the recommended mortar? 1:5 to 1:6. So that is enough for a masonry unit. Rich mortar definitely may create cracks. And mortar thickness shall not be more than 10 mm. If in a masonry, you use English bond or Flemish bond, okay, whatever may be the masonry unit you use, the distance between two masonry brick units should be within 10 mm or maximum 10 mm. The thickness of mortar, if it is more than 10 mm, there is a chance of shrinkage cracks, okay, and the expansion cracks. So mortar thickness should not be more than 10 mm. The curing as soon as possible and continue for 7 days. People use good quality cement. Okay, they construct. Next day, all the masons on leave means there is no. It is a child without milk. Okay, so that definitely there is a chance of cracking. So minimum 7 days curing. Most of the people do another mistake. They construct today, day after tomorrow they start plastering. So it should be cured for 7 days in masonry units. Then only go for plastering onto other further works. In masonry works should be proceed with uniform level. If you construct a one floor area, one side of the wall is 2 meter height, another side is 1 meter height, means there is a chance of different height and then different weight that creates a joint cracks. So all over the surface maintain same level. One day 1 meter means provide 1 day 1 meter or 1.2 meter. So like that, some precautions should be maintained in the masonry. And another headache in civil engineering is corrosion. People use very good cement, people use very good steel. But why still the corrosion cracks comes? Steel is susceptible to corrosion in spite of good manufacturing technology and all. Because there is two types of corrosion. One is surface corrosion, another is galvanic corrosion. You purchase a steel and pour it in the outside. Even after 1 year, only the surface only get corroded. The inner core is still very strong. But what happened in RCC? The steel reinforcement corrode when exposed to embedded concrete, there is chance of some minor cracks on the concrete surface. When there is a minor cracks on the concrete surface, there is a moisture may go inside. When the moisture goes inside, there is a cracks, there is a bulging of the Fe become FeO. The FeO forms around the rods, thus create an osmotic pressure. That pressure burst the concrete and then make a better, make still more wider opening. The still more wider opening creates more water and air to accumulate around your steel bars, and there is a continuous reactions and make the structure like this. The volume increases and rebar burst. Here the volume of the rebar increases, it burst the minor cracks into wider cracks. So this is a continuous chain reaction, and then if most of the people do a mistake, for the further development, they allow the double bars above their buildings or an horizontal manner also. That they are inviting corrosion. Because outside there is a moisture, inside there is protected against corrosion. But outside FeO, inside Fe. So there is ion exchange that create galvanic corrosion. So there is a most of the times there is a corrosion happens that they chip it off and plaster it, then that may become still more weaker in another few months. So the latter and the joints, we use 40 variety of material in the buildings: concrete, steel, masonry, wood, tile, paint. So like that, small material, bigger material, we are using 30 to 40 variety of materials. Different material has different coefficients. The different coefficients, mostly thermal expansion contraction coefficients, that creates cracks of susceptible crack. The masonry and plastering joints, okay, there is chance of cracks. Masonry and wooden joints, here there is a chance of cracks. So here a good masons, what they do after plastering, they make a groove. Okay, this groove should be given. Good masons only do. Other masons simply plaster and went off. Okay, you make a small groove at the wood and plaster joint, then you avoid cracks. Otherwise, there is a cracks, the people get along and then they complain about you. So the small things leads to perfection. And the RCC masonry tile joints, okay, where the tile joints, that means proper spaces should be provided. People make joint-free tiles and then there is a chance of cracking. Working construction joints, you cannot construct the entire thing in a whole day. So there is a step-by-step construction is there. So and the construction joints should be properly maintained and properly constructed. Otherwise, there is such cracks. And the old and new constructions, there is today you construct something, tomorrow maybe leave, or another 3-4 days maybe leave, and then people start for further construction. Okay, or there is a long leave like Pongal Diwali holidays. People come after 1 week or 10 days. Then during the 10 days, the previous concrete or previous masonry may get sink and set. The new masonry and new concrete does not sink and set. There is a joint cracks. And the expansion joints, okay, people has to properly calculate what is the expansion and how much is the expansion joint required. They make thumb rules and then expand. Most of the expansion joints are leaking. There is no proper treatment for the expansion joints. And building separation joints, we have to properly separate the buildings. Okay. In case of openings, this you may have seen in many buildings. Okay. You may take your shirt. In your shirt, there is a button. Around the button, there is a stitching. Your tailor knows better than your actual engineer. Okay. If there is an opening, you have to properly reinforce it. Okay. There is because most of the times this happens because of the sinkage of the lintels and sill beams. And here, in case of masonry structure, above that the load is applied. From the lintel, the load is transferred. Here area is more, here area is less. Okay, so here stress is more, here stress is less. There is a joint, under the joint there is a stress variation, there is a chance of cracking. And more general cracks are possible here. Okay, due to thermal expansion of the best way to provide a lintel is precast lintel, but it is a little bit cumbersome for the workers. So, but wherever possible, use precast lintels. So the sinkage of the lintels and avoid the cracks above the lintels. The expansion joint, this is the old method of giving expansion joint. People are giving like this. Because of this, there is a lot of leakages, okay, in expansion joints. Nowadays, the modern rubber material comes like this, and metal material comes like this. This creates very nice expansion joints as well as waterproofing. Okay. Soil swelling and heave. People construct buildings on the soil where clay soils are there. People worry mostly about the foundations, but least bother about the flooring and the outer flooring, where the heave due to swelling of soil. Okay, this type of cracks comes. So how to avoid it? Remove the clay soil, replace with quarry dust or some better non-swelling soil, or you have to move for lime treatment. Okay, calcium treatment. So this type of swell sinks are very common. Even in IT parks, I can test. Some IT parks, they condition and all. They least bother about proper filling. Okay, they do not use proper filling material. The filling material may have clay content. The clay content may swell and sink, and then there is a heaving and sagging of floor slabs. One person is talking about the foundations. Yes, here you can see the two towers are kissing each other because of one tower's pressure bulb is like this. Another building is considered very close to that. The pressure bulb is like this. The two pressure bulb overlaps. Here the soil is stressed more. The soil makes shear failure and then make the tilt on the building. And another is settlement. If there is no settlement, no cracks. With all the columns settle uniformly, again no cracks. But in differential settlement, you have to be very careful because the differential settlement not only creates the settlement cracks in the ground floor building, even in the terrace. Okay, you can create this. Okay, this is one of very interesting story. One of my friend called me. He said weathering course tiles are cracking. I gone there and went and said remove the weathering course tiles and relay. He relayed after 6 months again. If there is a cracks, again we relayed and we make some all them good material and all. Again after 1 year, again it cracks. Then we found there is a settlement. Foundation settlement. So foundation settlement not only leads to the masonry cracks, even in the ceiling may cracks because of the foundation settlement, differential settlement. Okay. And premature removal of formwork, as I said earlier, because of some compulsion, they remove the formworks. This concrete might not achieve the entire strength, expected strength. So where there are heavier sections, there may be somewhat withstand. And the lighter section joining there is a chance of cracking and more chance of crash sagging also. So that creates cracks on the buildings. Fire damage. People construct how build a building, commercial buildings. In commercial buildings, they do a very good interiors. Most of the interior materials are plywoods and curtains and all. They accelerating material. For some reasons, if there is a fire created, it prolong the fire ratings. Then 2 hours, 3 hours, 4 hours, fires may be possible. The cement mortar converted quick line in 400 degrees Celsius. From the lime you are converting into cement. This am I audible?
Yeah, you are audible now, sir, but a lot of interruptions, I would say.
Can you see the fire damage slide, ma'am?
No, sir.
No?
No, sir. The screen is not visible.
Okay, I'll go back.
Am I right, Joe?
Yes, ma'am. The videos are visible, but the screen is not shared.
Now it's seen, sir. Yeah.
Now? Now, ma'am?
Yes.
Yes, sir.
Yes.
Yes. I explained about fire damage. Fire damage make the concrete weaker. Once the concrete weaker, concrete is fall down, concrete is fall down, there is steel get exposed. Steel is highly vulnerable to heat. It bend off. When it bend off, then furthermore collapse of concrete. Vegetation. People, there is a proverb, வீட்டுக்கு ஒரு மரம் வளர்ப்போம். Every tree, every house have every tree. Every house has one tree at least. So, okay. But if you plant a tree, you have to pour water. Otherwise, trees are smart enough than us. They know where is our water. Okay. Where is their water? They send their root into our building. Below the plinth, there is a moisture prevention. They suck the moisture. When the trees goes into a building, okay, the sucking of moisture create sinkage of floor, and then the tree roots may uplift, create a moment on the structure that create cracks. So if you plant a tree, everything is okay, but pour water. If you don't pour water, your tree may damage your building. How to prevent cracks? One is choice of materials, another is specifications, third one is architectural design, another is structural design, construction practice and techniques, and environmental protection. These are all the things to prevent cracks in the building. How to monitor a crack? Okay, there is a crack comes in your building. First you have to, so don't suddenly start the repair. You have to monitor whether a crack widens or the crack closes itself, or it is standstill for several months. Okay, most of the people don't have patience, so they suddenly go and make applications with the masons and all without proper professional advice. Again, after 5 months or 6 months, again there is a crack. So you have to observe how there is a thing called small glass plates, what you use for blood test in labs, or there is a crack meter. The crack meter is nothing but there is a glass plate with the divisions. You can stick it on with glue. Okay, stick it on the cracks. Or if you can use paper also, small piece of paper, or to stick a piece of paper. Okay, you stick a piece of paper. If the crack widens, the paper tear off or the glass get broke, then is a warning the crack is progressive. For several months, more than 6 months, nothing happened to the glass pieces or the paper, means the crack is dormant. The crack comes, after that, nothing to worry. So we can easily attend. If the crack is active, you have to find out where is the reason for the cracks. And then first stop the source of action to which create the cracks. Bonding with epoxies, routing and sealing, stitching, external stressing, overlays, grouting, corrosion repairs. These are all the repair techniques. Let us go one by one. As I said, people construct one type of concrete this week. Okay, next day or next few days, they construct continuous concrete. Then they have to, without a bonding agent or without a bonding coat, if you construct the concrete, there is a sinkage cracks. So they have to provide a bonding agent with the epoxies. Yeah, this is a famous bonding coat is Nitobond XP. Yeah, that bonding coat, if you apply on the existing concrete, and then you can construct further concrete. So this is one type of crack prevention technique in concrete continuation. Another is, okay, in a concrete surface or a brick surface, there is a mild crack you can see, less than 1 mm or 1 mm cracks. How you are going to seal it? So it is very difficult to seal such a crack because we don't have any tools to apply on it. So make a groove on the crack. By proper tools, you make a groove so that you can apply a sealant. Mostly polysulfide is a material used as a sealant. There are other sealant also: silicon sealant, polyurethane sealant, Depends on requirement. If you want the crack should be crack only be sealed, polysulfate sealant is okay. If you want the crack should be watertight, you have to use for polyurethane sealant. So make a crack wider by grooving and then put a sealant. Another is stitching. How our cloths are stitched. Okay, this is a vertical view. This is a horizontal view. Okay, this is a masonry. There is a cracks develops on the masonry. Drill a hole here, drill a hole here. Okay, and then you make a rectangular U-shaped steel rod, grout it inside the masonry or the RCC, and then you properly seal it like this. So what happens if there is a crack tend to bend, may tend to bend, this rods does not allow to expand. Okay, so no further cracks. This is one of the very good successful method. Many sites we did it. So this is one method of crack stitching. And this external stressing, you might have studied about pre-stressed concrete. In this, there is a chance of cracks in the slab. How to avoid because of sagging of slab? The beams are okay. Only slab only vibrates or slab only cracks or slab only sags means drill a hole here, drill a hole here, put a strong rods and then tighten it with bolts. So it does not allow the expand the further sagging of the slab. Okay. If the beam also sags, cracks, so you have to provide a detailing like this. You steel plates with gussets in opposite sides also, and provide a rod like this. This when the beam try to bend, this the rod get tension and does not allow. It is like a pre-stressing technique. This is an external stressing technique. So this is one method. This is mostly a temporary method because people don't want to see this type of rods in their buildings. So we have to go for any further the crack repair techniques. This is steel plate overlays. If there is a sagging of slab or a beam, they put a epoxy and put a steel plate, or they bolt it with the chemical grouts and then put a bolt and put a steel plate, or mechanical anchors, or they put a steel plate on one side or the through bolt and then put another steel plate. So this is one type of steel plate overlay. And where there are cracks, people inject the chemical called epoxy. So epoxy go inside the epoxy is a much better binder than cement. So it goes inside your cracks and then bind the crack. So this type of loading with epoxies. And corrosion repair. We have seen about elaborate about how the rod get corroded. When the rod get corroded, the concrete surface get cracks. People can simply ask a mason and then remove the corroded surface and then again replaster or reconcrete. Within a few months, again the corrosion occurs and then it continuously cracking. So how to avoid it? Step number one, you have to remove entire cover concrete, okay, and then expose your steel rods, and then remove by sandblasting or emery paper or corrosion removal chemicals are there, or you have to there should not be a corrosion on the steel like that. You have to remove. When you remove, definitely the diameter may get lost. The 16 mm rod become 12 mm or 10 mm. You have to use a vernier caliper. What is the original diameter of the rod and what is the diameter after removal of the corrosion? If the corrosion is more than 20%, if the corrosion loss is more than 20%, then you have to weld additional rod. Otherwise, you can proceed. Otherwise, if the corrosion is more than 20%, then you have to weld additional rod. And then apply anti-corrosive paint on the steel rebars. And also, as I said, bonding coat, nitto bond on the existing concrete. Then apply the fresh concrete, okay, or micro concrete. or screed concrete on the reinforcement, and then finish with fine mortar and properly paint it out. This step-by-step procedure should be there. People do not use this method because of it is a very skilled job. They simply call the masons and then they cover it with mortar or local concrete. Again, within few months, it again cracks. So remove the corrosion, remove the cover concrete, remove the corrosion. If there is a loss more than 20%, you got to build a further reinforcement. Apply corrosion resistant paint and apply bonding coat. Provide additional screed concrete or micro concrete and then mortar finish. This is how step by step you have to make corrosion repairs. Let us come to conclusion because crack repair is a very big topic. Within 1 hour, it is very difficult to cover all those things. But to my best, I covered what is the reason, what are the materials to be handled, how the cracks to be repaired. Like that, cracks are symptoms. Okay. I am coughing, I am sneezing. That means I may have lung infection. Okay. I may have some bacterial infection. So similarly, if there is a crack, the building is saying that I am not well, take care. The cracks may not be a structural crack. All cracks need not be a structural cracks. Okay. So there may be a plastering cracks also, or sinkage cracks also. There are non-structural cracks are also possible. Cracks should be thoroughly analyzed and monitored before going for repair. As I said, you have to paste the glass pieces or put the papers and then monitor whether crack opens or the crack is dormant. If required, better to conduct non-destructive test around the cracks. Okay, it is a little bit costly, but if you conduct a non-ultrasonic pulse velocity test like that, non-destructive test conducted, that shows little more accurate results. Depends on type of crack and classification of cracks, the repair techniques. All the place you cannot go for sealant. All the place you need not go for stitching. All the place you need for grouting. So which type of cracks, which type of classification, what is the consequences? Based on that, there is no one medicine for all disease. Okay. Similarly, depends on types of cracks. There are types of repair techniques. Skilled manpower and skilled tools are emphasized in crack repairs, not regular masonry works, not regular concrete works. You can simply attend the cracks. There are people required as proper training, and then the skilled manpower and skilled materials and tools and for injection of epoxy and all, the epoxy pumps are required. So that is required for crack attempts. After repair rehabilitation, the cracked buildings should be monitored. Okay, you attend the building, you apply some method. Okay, only during the course of time only you can ensure your method is correct. So 90% of the building, even though good applicators are attending the crack repairs, only 90% cracks get guaranteed. There is reoccurrence of 10% if even very skilled people attended. So if there is unskilled people attended, means there is more than 50% chance. So we have to ensure periodical monitoring whether the crack reoccurs. If the crack reoccurs, no worry. If there is reoccurs, then you have to view very critically. Thank you very much for your patience. He is Professor Peck. He is my godfather in civil engineering. He is the most respected professor in soil mechanics as well as in civil engineering. He written his autobiography, First Lines. Civil engineering is not an intellectual practice, even it was intellectual content, but it is action oriented. So if there is a crack, you want to go and study, okay, step by step study what is the reason, and then revisit and then apply your proper methodology, and then you ensure a proper repair. Once again, thank you very much. Thanks for your patience. I apologize for some interrupts during the signal loss and all. If there is any further discussions, we'll proceed. Thank you.
Sure, sir. Sir, thank you so much. And though there were a lot of cracks and interruptions in between during this session, it was really an enriching session, I would say. And there are a few queries in the chat box. I think Joe can help us with that.
Yes.
Thank you, sir.
Yes. So we have a question from Mr. DP Saravanan. If we are adding new reinforcement to the existing corroded bars, is it possible to weld properly?
1 minute. The Rajesh that is not satisfied with the answer. SPC of the soil plays a major role with structural design in clay soil. Can you avoid cracks? SBC of the soil is a self-bearing capacity. Okay, you achieved a good bearing capacity, and your pressure is less than the SPC. Does not guarantee your building is safe, because you have to make, there is one more analysis that is called settlement. You have to find out what is the immediate settlement. You have to find out what is the controlization settlement. The both settlement should be within limit. If the both settlement is within limit, then only there is a chance of the foundation is safe enough. Okay, so people, most of the structural design engineers go get the soil report, go to the last page, study SPC at 2.5 meter or 3 meter is this much kilonewton per meter square. They achieve. That does not guarantee. You have to find out what is the chance of settlement. In case of clay soil, there is a chance of soil sink, not only bearing capacity. There is a chance of swelling. If there is a monsoon time, the water penetrate into the soil mass, it will increase the double layer and the soil may swell. Your foundation may not be sufficient to design swelling. There is a chance of cracks. Okay. If you are adding new reinforcement to the existing corroded bars, is it possible to weld? Yes, we have to weld properly. How to weld properly is given in SP 34, special publication 34. It is a additional code to IS 456. How to weld? There is a specification is there. Maybe I missed it, but what are there any new technologies or techniques detect cracks? Cracks are visible nowadays. Okay, always cracks are visible. Okay, there are minor cracks which is not visible, which can be ensured only by using ultrasound. Okay, you have to use ultrasound waves passed into your concrete, and if the concrete velocity is less than 3.5, there is a lots of minor cracks and porous. Best rectification chemical depends on type of cracks, depends on the porosity, depends on a lot of chemicals are there. Mostly people use polymers and epoxies. Okay, polymers are nothing but the chemicals that is introduced into the concrete, and then it react with the cement. It does not follow further porous. And epoxy is a material, is a resin. It is injected into the cracks. It will seal the concrete. It bind better. It does not allow further seepage of water through a crack. And it also improves the, if there is no porosity, if there is no water seepage on the concrete, definitely the strength will be good. What about the image processing technique for detecting cracks? So far, I don't have any experience on image processing techniques. Excellent presentation. Thank you very much. Okay, thank you. Next, anything? One is my professor, Rajayogan, also congratulated me. Thank you, sir. He is my HOD. We have more than 25, 30 years of regular follow-up. Even one person doubt, I call him. He clarify my doubts. Still, I am a student of him. Any further questions I missed? I think that what are all the factors? The factors which are reason for crack detect, proper investigation, site structural design, old construction practice. So I am working as a executive engineer at considering many structures. I am Rajesh, ME Structural Designs, MBA Project Management. Okay, then. Any further queries or any questions? Am I clarified all of yours? Other than image processing, that
Yes,
may be infrared, the infrared detections. But in crack repairs, we trust ultrasound. Okay. Then.
If there are no further queries, I think we can move on to the vote of thanks. Okay. There's one final question, sir.
Yes.
Somebody is asking, what if cracks occur on the beam rebars near support columns? If we weld, how will the anchorage support?
There is a famous chemical company called Hildy. They give a catalog. What is the anchorage length? Minimum anchorage length for the reinforcement to be used if you anchor a rod for stitching and all. Minimum 10 times dia. Minimum 10 times dia. Okay, preferably 15 times dia. Yes, why it is 15 times dia? If there is a chance of fire. If there is a fire, go for 15 times dia. Normally 10 times dia. If you use 8 mm rod, you drill a hole for 80 mm and then you have to inject the chemical, the Hildy chemical or Fisher chemical or phosphorus chemical, and then you put a rod for the binding purpose, and then you have to ensure the anchorage. What is a crack occur on the beam column, rebars, and the support columns? So if we weld, how anchorage support? Normally, there is a discussion about corrosions. I think the gentleman asked about that weld. The weld is mostly the corrosions in the beams comes in the middle. It will simply supported beam. Because this is also called stress corrosion. The flexural stress is more in the mid span, and there is a more chance of cracking in the mid span. So the welding mostly in mid span. Always the L joints, the beam column joints are safe, but if the beam column joints also get corroded, then the operation will be very, very challenging and difficult. We are doing that also. For that, we have to open the beam column joints and do the surgery very properly and ensure the anchorage. Sir, a basic lecture on concepts of cracks, very useful. Students get. Thank you. Kalyana Sundaram is a superintendent engineer, PWD. Yes, thank you very much, sir. Okay. I think Rajesh Datta is somewhat satisfied about my lecture because that is a different topic. Soil system interaction, bearing capacity, settlement, and leads to cracks is a very elaborate subject. We deal about that also, foundation failures and foundation settlement. Next lecture, ma'am.
Oh, sure.
Okay, ma'am.
Definitely, sir.
Okay.
So I think we can conclude with the Q&A session.
Okay.
So
thank you very much. Thank you all.
And, on behalf of the Department of Civil, I would like to extend a heartfelt vote of thanks to Mr. Karthikeyan for his illuminating technical talk on cracks in buildings. It was indeed a pleasure to have Mr. Karthikeyan as our esteemed speaker, and we are immensely grateful for sharing his knowledge and expertise on this critical subject. Throughout this presentation, Mr. Karthikeyan provided us with an in-depth analysis of the causes, its preventions, remedies, and the effects of cracks in buildings. He highlighted the importance of identifying and understanding these cracks and their underlying causes to prevent any severe damages to the structures. So I think I speak for everybody in this panel when I say it was a very useful and insightful session, sir, and I thank you so much for this session. I would also like to extend my extreme gratitude to the Department of Civil Engineering, the HOD, Dr. Vandana Devi ma'am, and all the faculties involved for their continuous support and guidance, and for their effort and commitment in organizing such an excellent seminar. Their efforts have been instrumental in making this seminar a huge success. So thank you. Thank you everybody who attended this seminar, and thank you so much, Mr. Karthikeyan, sir, for taking the time and effort to prepare such an informative and thought-provoking presentation. And we hope to have the pleasure of hearing from you again, sir.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you so much, sir.
Thank you. Thank you.
Thank you.